Hello people, today we are going to talk about isomerism. So what are isomers? Well, isomers are different molecules. They are very different molecules that happen to share the same molecular formula. That happen to share the same molecular formula. So what do I mean by this? Let us take an example. Let us look at these two molecules. Do you think that these two molecules are identical to each other? Of course not, right? Howsoever I try to rotate and revolve the molecule on my right, whatever way I look at it, we can clearly see that these two molecules are very different. They are not identical to each other in any way, right? Now, if we try to calculate the molecular formula of these molecules, let us see what do we get. Well, the molecule on my left, in the molecule on my left, these black atoms, they represent carbon, while the white atoms represent hydrogen. Okay, so the molecule on my left has 4 carbon atoms, so clearly it has a formula of C4, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it has 10 hydrogen atoms, so this has a molecular formula of C4H10. Similarly, the molecule on my right also has 4 carbon atoms, right? So this too is a C4, and this too has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. So this too has a molecular formula of C4H10. We have seen that these two molecules are very different, but just because they happen to share the same molecular formula C4H10, that's why we call them isomers of each other. Okay, if I try to draw the bond line formula of the molecule on my left, then can be represented like this, while the molecule on my right can be represented like this. If I try to write their IUPAC names, the molecule on my left has 4 carbon atoms, so this is essentially a butane molecule. It's an alkane, so it's essentially a butane molecule, while the molecule on my right has a word root of prop, since there are 3 carbon atoms, so this is basically a propane with a methyl group attached at the second position, so this is 2-methyl propane. So clearly these two molecules even have different IUPAC names, right? So they are different, they are not same, they are very different molecules, but just because they happen to share the same molecular formula C4H10, just by coincidence, that's why we call them as isomers of each other. Let us take one more example. Do you think that these two molecules are isomers of each other? Take a moment and think about it. Well, the molecule on my left has 4 carbon atoms, right? So this is a C4, and it also has 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogen atoms attached. So this is a C4H9, and let us say that this is a bromine attached out here, so this has a formula of C4H9Br. Similarly, the molecule on my right also has 4 carbon atoms, C4, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogen atoms, and a bromine atom attached out here. So this too has a formula of C4H9Br. So are these molecules isomers of each other? Are these two molecules isomer of each other? The answer is no. We can see that just by simply rotating the molecule on my right, we get the molecule on my left, right? So essentially these two molecules are identical to each other. They are identical, right? So they are the same molecule. So if I try to draw the bond line formula of the molecule on my left, this can be represented like this, with a Br atom out here, and the molecule on my right can be represented like this, with a Br out here. So at the first instance, these two molecules might look different, right? But as we have seen, simply flipping the molecule gives me the other molecule. So they are essentially identical to each other. And in fact, if we try to write the IUPAC names of these molecules, we are going to get 1-bromobutane, right? We are going to get 1-bromobutane in this case. And similarly, in the other case, we are also going to get a 1-bromobutane. So these two molecules even have the same IUPAC name, right? So they are identical to each other, and they are not isomers of each other. So they are not isomers, they are identical. Let us take one final example. Do you think that these two molecules are isomers of each other? Well, let us analyze. Let me label my atoms. This is a hydrogen atom. Let the blue one be the bromine atom. Let the red one be an iodine atom, while the yellow one, let it be a fluorine atom. So essentially the molecule on my left can be drawn like this: carbon, hydrogen, bromine. We have an iodine atom coming out towards us, and we have a fluorine atom going away from us, right? Similarly, the molecule on my right can be redrawn as carbon, hydrogen, bromine. We have an iodine coming towards us and a fluorine going away from us, right? If I try naming the molecule on my left, this is essentially a methane molecule. This is essentially a methane molecule from which we have removed some hydrogen atoms and replaced it with bromine, fluorine and iodine atoms. So this is essentially 1-bromo, 1-chloro, 1-fluoro methane, right? Similarly, if I try naming the molecule on my right, these two will be named as 1-bromo, 1-chloro, 1-fluoro methane. So these two molecules have the same IUPAC name. Okay, so are they identical molecules? Are they identical? Let us see. Let us try rotating the molecule on my right. Howsoever I keep rotating the molecule, we can see that these two molecules never really coincide, right? The molecule on my right does not actually resemble the molecule on my left. There is some difference. In this molecule, we have a carbon atom at the center. We have a hydrogen atom out here, a bromine atom out here, right? And as you can see, we have the iodine atom coming towards us, while the fluorine atom is facing away from us. This is when we are talking about the molecule on the left. If we compare it with the molecule on the right, we have a hydrogen atom out here, a bromine atom out here, but this time the fluorine atom is facing towards us, while the iodine atom is going away from us. So we can clearly see that these two molecules, in spite of having the same IUPAC name, they are different, right? They are different molecules. They are not the same molecule. So thus, these two molecules are isomers of each other, right? So let us revisit the definition of isomers once more. What are isomers? Well, isomers are different molecules. They have to be different molecules that happen to share the same molecular formula.